Hope you will be fine. Welcome to PMDC online lecture room, Ashfaq Ahmad Physics Department. Dear student, today we will discuss centripetal force and centripetal acceleration. If a moving object has no force acting on it, it will continue to move in a straight line at constant velocity. So if an object is moving in a circle or along the arc of a circle, it follows that there must be a force acting on it to change its direction. Moving in a circle means that the direction of motion is constantly changing. This in turn means that the direction of the force is constantly changing. From Newton's second law, we know that force is an agent which produces acceleration in a body along its direction, or tend to produce acceleration in a body along its direction, partially or completely. Centripetal force is basically inward force which directed along the radius and tend to produce centripetal acceleration in the body. So how we can define centripetal force? Centripetal force, the force which compel the body to move in circle, is called centripetal seeking force or centripetal force. For example, a body tied to a string and whirled in a horizontal circle, centripetal force is provided by the tension in the string. So in this diagram, tension T, which is directed toward the center of the circle produced in the string, this tension T is responsible to produce necessary amount of centripetal force for revolving body. During revolution, the body tend to escape from circle along tangential path. So we can say that this velocity is tangential velocity. So at each point the body want to escape from circular path. Centripetal force is responsible agent which keep the body in circular motion. Before find the relation or mathematical formula for centripetal force, we have to explain centripetal acceleration. An object moving in a circle is experience acceleration even if moving around the perimeter of the circle with a constant speed. There is still a change in velocity and subsequently in acceleration. The acceleration produced due to the change in direction of velocity is called centripetal acceleration. This acceleration is directed toward the center of the circle. Acceleration produced due to change in magnitude of velocity as well as change in direction of velocity. So if we consider uniform circular motion, so uniform circular motion means that there is no change in magnitude of velocity. But during circular motion, uniform circular motion, at each point direction of the particle is changing at each point, at each instant of time. So in this case, acceleration produced in a body due to change in direction of particle, and this acceleration is called centripetal acceleration, which is directed toward the center of the circle. Dear student, consider a body of mass m moving in a circular path of radius r as shown in figure with constant speed v. So at each point its magnitude of velocity is constant. Mean velocity at point A, velocity at point B and velocity at point C are having same value but different direction. The angle BAC and angle RPQ are equal because perpendicular over line has the same angle as the angle between the line. So when the angle delta theta, delta mean small change, theta mean angle, are angular displacement. So delta theta is very small angular displacement. Delta v is equal to magnitude of v, approximately equal to the circular arc between the tip of the vector v1 and v2. So from head to tail rule we can write that delta v is equal to v2 minus v1. Now applying the equation s is equal to r delta theta, so we replace s by delta v and r by v. So delta v is equal to v delta theta, dividing delta t both sides and apply limit delta t tends to 0. Why we applied limit? Because we have to find angular velocity at each instant of point, at each instant of time at any point p. So delta v by delta t is equal to instantaneous acceleration, and delta theta by delta t is equal to angular velocity. So we can write that acceleration is equal to a is equal to r omega. AC is equal to v omega. So we can write that AC is equal to v square divided by r, as in vector form AC is equal to minus v omega r omega. Minus represent that AC is directed toward the center of the circle and r unit vector represent direction. So we can find more than 2 or 3 vector form of centripetal acceleration. Now we come to our original topic, which is centripetal force. So from Newton's second law, you know that F is equal to ma. So we put value of centripetal acceleration in this equation, which is equal to FC is equal to mv square divided by r. Now in vector form we can write that FC is equal to mv square divided by r into r unit vector, and another form is mv square divided by r square into r vector. You can write more than 2 or 3 vector form of centripetal force. In home assignment, dear student, find centripetal acceleration of moon having radius 3.2400 kilometer. What is the moment of inertia of a 100 kg sphere whose radius is 5 centimeter? And the last one is a wheel having radius 40 centimeter revolving 100 revolution per minute. This 100 revolution per minute is the angular velocity of the wheel. So find its centripetal acceleration. These are your home assignment. Best of luck. If you have any problems, so contact with the respective teachers.